Have you ever stopped to think about what's going on, like deep beneath your feet, right now? Today, we're diving into one of the most powerful and, honestly, awe-inspiring forces on our entire planet, volcanoes. And trust me, they're way more than just fiery mountains. They're like a window into the Earth's molten heart, a direct line to the incredible power that's churning just below the surface. So let's do this. I love this quote because it just nails it. Think of the Earth as a giant pressure cooker. All that insane heat and pressure deep inside has to go somewhere, right? Well, volcanoes are the planet's essential release valves. They stop a much more catastrophic buildup. So yeah, while we see them as destructive, they're actually a crucial part of what keeps our world stable.
Okay, so to really understand what makes a volcano tick, we've got to look under the hood. Let's take a little journey together, starting way down deep inside the Earth and working our way all the way up to the top.
Way down beneath the surface, you'll find the heart of the volcano, the magma chamber. You can pretty much think of it as the engine room. This is this huge underground cavern that's filled with super hot molten rock. That's magma. And this is where all the incredible energy for an eruption just builds and builds and builds.
So how does all that molten rock actually get out? Well, it needs an escape route. It blasts its way up through the vent. This is the main highway, the direct pipeline that connects that deep, pressurized magma chamber to the outside world. When that pressure just gets to be too much, this is the path it takes.
And that journey's end? It's right here at the crater. This is that iconic mouth of the volcano, that big bowl-shaped opening you always see at the summit. It is the final exit point for all the lava, all the ash, and all the gas that's about to be completely unleashed.
Okay, here's a super simple but really important point. While that molten rock is underground, we call it magma. But the second it erupts out of that crater and starts flowing on the surface, its name changes to lava. It's the exact same stuff, just in a different location.
But an eruption is so much more than just oozing lava. A massive part of the whole event is the ash cloud. And this isn't just smoke, okay? It's this enormous plume of pulverized rock, superfine dust, and scorching hot gas. It can be blasted from miles up into the atmosphere, and it's powerful enough to mess with weather patterns and ground air travel across entire continents.
So where does that classic pointy volcano shape even come from? Well, get this. The volcano builds itself. Over thousands and thousands of years, with every single eruption, layers of cooled lava and fallen ash just build up and up and up around the vent, creating that cone-shaped mountain we all recognize.
So we've seen all the parts, but how does a volcano even form in the first place? Let's get into its origin story. It's a pretty epic tale of incredible heat, immense pressure, and a whole lot of time.
This pretty much lays out the whole life cycle. It starts way down deep in the Earth, where the heat is so intense, it literally melts solid rock into magma. Now, this molten rock is less dense than the solid rock around it, so it naturally starts to rise up, collecting in that magma chamber. As more and more magma flows in, the pressure just builds and builds until it becomes absolutely unstoppable. That's the trigger for an eruption. And of course, with each one of those eruptions, the cooled lava and ash add another layer, slowly building that mountain over millennia.
Now here's where it gets really fun. Not all volcanoes are the same, not by a long shot. In fact, they have really different shapes and behaviors, almost like they have their own unique personalities. And what determines that personality? Well, it all comes down to how they erupt.
So, first up, you've got your shield volcanoes. These are the big, gentle giants, like Mauna Loa in Hawaii. They're formed by runny lava that just flows for miles and miles. Then you have the classic steep-sided composite volcanoes, like the famous Mount Fuji. These guys are built by much more explosive eruptions of thicker lava and ash. And finally, you have the smaller cinder cones, which are basically just hills built from explosive bursts of ash and rock.
And we can also sort them by how lively they are. An active volcano, like Mount Etna, is one we know erupts pretty regularly. A dormant one, think of it as a sleeping volcano, like Mount Fuji, hasn't erupted in a long time, but it could definitely wake up again. And then you have an extinct volcano, like Kilimanjaro, which is one whose internal plumbing has basically been shut down for good. It's not coming back.
Volcanoes have such a profound impact on our world. I mean, they're famous for their destructive power, of course, but you know what? That's only half the story. They are also one of Earth's most powerful creative forces.
This whole duality thing is just fascinating. On the one hand, yes, an eruption brings destruction. But on the other hand, that very same volcanic ash breaks down to create some of the most fertile soil on the entire planet. And lava flows don't just destroy things, they literally create brand new land. The entire Hawaiian island chain was built this way from the ground up. Not to mention, they're also a source of valuable minerals and clean geothermal energy.
So where do we find most of these fiery mountains anyway? Well, a huge majority of them are located along the Ring of Fire. It's this massive, horseshoe-shaped belt that stretches all the way around the Pacific Ocean. And that's exactly why countries like Japan, Indonesia, and the west coast of the United States are such hotspots for volcanic activity.
All right, let's just recap the big takeaways here. First, volcanoes are the planet's essential safety valves, releasing all that internal pressure. Second, they're born when that immense pressure forces molten rock right up to the surface. Third, they've got their own personalities, and we can classify them by their shape and their activity level. And finally, and maybe most importantly, they are these powerful dual forces, capable of both incredible destruction and breathtaking creation.
Which kind of leaves us with one final thought. Volcanoes build new worlds from scratch, and they can destroy old ones in an instant. They create the most fertile land and also the most barren. So, what do you think? Are they the villains, or are they the heroes of our planet story? Or maybe, just maybe, they're just a vital, wild,